So up till now, we've been looking at equilibrium situations that involved the same phase from reactants and products. Well, what happens if you have multiple physical states, gases, liquids, solids, involved in your expressions? How do you deal with that? So this is called heterogeneous equilibria. Heterogeneous meaning different, okay, different species. This will involve more than one phase, so not all gases or aqueous solutions or whatever, okay? The position of heterogeneous equilibrium doesn't depend on the amounts of pure solids or pure liquids involved in the reaction, okay? Their concentrations don't change, essentially, in terms of particles. There's so many of them. And they're pure, okay? They're pure. They're not made of anything other than the molecules or formula units or whatever of those substances. So we don't include them in our expression for the equilibrium constant. Okay, that's important. So we don't include liquids and solids that are pure. Only gases and aqueous solutions get included. Okay, so if you were to do this reaction where we have calcium carbonate decomposing into calcium oxide and carbon dioxide, the pure solids that are involved here, they don't really affect any of the behavior of what's going on above them. So they don't affect the pressure for sure, right? And they don't, if you're at equilibrium, right? And they're not going to change very much. The amount of calcium oxide and calcium carbonate may change, but the overall masses are staying the same. And so they would factor themselves out of the expression. Okay, so just the important thing to remember is you just don't include anything that's pure liquid or solid. So here we have liquid water at equilibrium with hydrogen gas and oxygen gas. If we were going to write an expression for K, we would not include the H2O. We would only include the products in this case, H2 squared, concentration times concentration of O2. Okay, in this one, where we have gaseous water going to gaseous hydrogen and gaseous oxygen, we would include the H2O because it's a gas. And so you'd have to have the denominator for the reactants, H2O concentration squared, okay? So if it's a pure liquid or solid, it doesn't appear in your equilibrium expression. It's very simple, okay? That's how we deal with heterogeneous equilibrium.